Hello, today's video is going to be on graphing general rational functions. At the top you've got your first two equations, which are a review of ones that we've looked at already. What makes these simple is the fact that we are dealing with linear functions, which means it's going to be x to the first degree. And our first equation is when you have the higher degree on the bottom, and your horizontal asymptote is going to be that number added outside. Don't forget that that number could be 0, so if the higher degree is on the bottom and there's no number added, it's at 0. We also looked at equations that we had the same degree on top and bottom. Again, x to the first on top, x to the first on the bottom. When it's the same degree top and bottom, for that horizontal asymptote, we are looking at dividing those leading coefficients. What's going to make these a little bit more complicated is the fact that we could have something besides a linear equation. So these are going to be polynomials that have a higher degree. And like a lot of other times we have this big fancy equation, it looks a more complicated than it is. Because it's not linear, we're saying x to the m because we don't know what m is, and x to the n because we don't know what n is, because it can be any degree polynomial. Alright, so when we look at our important information from this polynomial, the vertical asymptote is going to be the same as what we've been dealing with. For the vertical asymptote, you're going to set the denominator equal to 0 and solve. Just like always, for your x-intercept, you're going to set the numerator equal to 0 and solve. And don't forget that the x-intercepts are we're only solving for the real zeros. And if it's the x-intercept, we know the x-intercepts are always going to be existing when y is equal to 0. And if we're looking for the y-intercept, we know that's when our x is going to be equal to 0. So if you want to find the y-intercept, all you have to do is substitute 0 in for x and solve for y. Now because we're going to be dealing with graphing these functions, you also could just solve on your calculator. Bunch of different ways that you can do that, but remember you can look at the table or you can use that value button underneath your calculation. Alright, next we have the horizontal asymptote. So this is the only aspect that's going to be different for different kinds of equations. Let's start by looking at that first simple equation that we've already looked at, and when you're here you've got the linear function on the bottom and a constant on top, which is going to make the higher degree on the bottom. So if the higher degree is on the bottom, the horizontal asymptote is that number that's going to be added on the outside of the fraction. This is going to be true for any degree polynomial, not just linear. So if the higher degree is on the bottom, then the horizontal asymptote is y equals whatever number is being added outside the fraction. And don't forget that if there's no number being added outside the fraction, then it's going to be equal to 0. Our other simple is when we have the same degree top and bottom, so a linear on top and a linear on the bottom. The same rule is going to apply, except for now we could have x squared on top, x squared on the bottom, x cubed on top, x cubed on the bottom. So if we have the same degree top and bottom, when that's the case, we have our horizontal asymptote when we divide the leading coefficients. And we know that the leading coefficients are the numbers with the degree. So not just necessarily the first constant, but the constant, that coefficient that's with the variable that has the highest exponent. So in this case, if we are looking at our general equation, our leading coefficients there are a sub m and b sub n. So y equals a sub m divided by b sub n. Again, that's for the same degree top and bottom. Both review, being applied from our linear functions. Now the new one, if the higher degree is on top, then there's no horizontal asymptote. All right, so let's go ahead and get started. Going down to the first one. First, our vertical asymptote. We know that if we want our vertical asymptote, it's about setting that denominator equal to 0 and solving. So x squared plus 1 equals 0. We move that 1 over where it becomes negative. We square root, and we get plus or minus I. Well, that's imaginary. We can't see imaginary asymptotes on our graph. So this time we actually don't have a vertical asymptote. For the horizontal asymptote, this is where we look at our 3 different situations. And according to this equation, we have a constant on top and a quadratic on the bottom. So the higher degree is on the bottom. And when the higher degree is on the bottom, we are looking for the number being added outside. There is no number being added on the outside. So your horizontal asymptote is y equals 0. Let's go ahead and go to our graph. Horizontal asymptote, y equals 0. And don't forget, when we're drawing our asymptotes, we have a dashed line because it's an imaginary line that our graph is approaching. Our x-intercept, when we are trying to solve for our x-intercept, we set the numerator equal to 0. Well, 4 equals 0, no variable, no solution, so there isn't an x-intercept. For our y-intercept, we plug 0 in for x. So 4 over 0 squared plus 1. 4 over 1 is just 4. So our y-intercept there is at 0, 4. All right, so now let's go ahead and get the graph of this. So we need to go to our calculator. When you look at the calculator, I've entered it in 2 different ways. When we are entering in the equation, we're going to hit alpha y equals. If you hit alpha y equals, it gives you the fraction format where you can enter in your numerator and your denominator. Or you can do for your division symbol, just make sure that you put the denominator in parentheses because we want to group all of that together. And you'll see that when we hit graph, well, let's do zoom 6, make sure that we're starting with a 10 by 10 window. There's our y1, and you can see that our y2, exact same equation. We want to go ahead and plot points here. We already know that we had that y-intercept at 0, 4, so we want to find points to the left of that and points to the right of that. We go to our table of values for that, and notice how y1 is giving us fractions and y2 is giving us decimals. We prefer decimals because it's easier to figure out where those points should be labeled. If I think about 2 over 13, it's not easy to recognize that location versus 0.1. So if we go back to our y equals, I personally would not use your alpha y equals because when you do the fraction format, it's going to give you all of your answers in fractions as well. So we want to use that y2 and we can get our decimals. We can see that point there at 0, 4. Next to it is negative 1, 2, negative 2.8, negative 3.4, and same on the other side. So go ahead and press pause. Plot these points on your graph and make your graph. Remember that you always want to plot the points that you are graphing. List them over there on this side. When we look at this, remember we have the asymptote. The asymptote's that imaginary line that our graph is approaching but not touching. So you want to make sure that your arrows are approaching that line but not touching, not crossing it. Which is going to bring us to our last part of this, the domain and range. Remember, the domain is your movement left, right? My arrow's forever going left, forever going right. There's no breaks in between, so our domain is all real numbers. Now when I look at the range, movement going up and down, the highest point on my graph is 4. It comes down, approaching that asymptote. It's not existing anywhere else between 0 and 4. So this is all real numbers. It can't be 0 because it's an asymptote. And it goes all the way up to 4 where it does exist. So that's why we have the less than and then the less than or equal to symbol there. All right, let's go ahead and turn over to the back side. Start with our important information, our vertical asymptote. That is our denominator set equal to 0. We get that positive 4 square root. that gives us our positive and negative 2. So we have x equals a positive 2 and x equals a negative 2. We've got 2 vertical asymptotes. So we go ahead and plot those on our graph. And at a positive 2, the horizontal asymptote is all about that degree. So when we look at our equation, I've got a second degree on top, second degree on the bottom. So I have the same degree top and bottom. And when that's the case, we divide those leading coefficients. So we look here, that's a 3 and a 1, making our horizontal asymptote y equals 3. We go to our graph again, we plot our asymptotes. The asymptotes would help us give shape to our graph. We go to our x-intercept, and the x-intercept is when we set that numerator equal to 0, so 3x squared equal to 0, x is equal to 0. Now whenever you have an x-intercept crossing at 0, 0, that's going to double up as your y-intercept. So we know we've got that point there at 0, 0. Let's go ahead and go to our calculator. Press pause, get your equation into your y equals, and get your points. We want to have 3 points to the left of our vertical asymptote, 3 points for the middle section, and 3 points to the right of our asymptote. Those points give our graph shape. All right, let's see how you did. We had that vertical asymptote at a negative 2, so when we went to our table of values, we were looking for the coordinates at negative 3, negative 4, and negative 5, making sure that we list those coordinates. In the middle, we have that x-intercept at 0, 0, so we're using the point to the left, point to the right, giving us that middle piece. And then on the right, since our asymptote's at 2, we use the coordinates for the point at 3, 4, and 5. So we look at our graph to figure out our domain and range. Our domain, as we go left and right, we do have a couple restrictions. We're never going to have an x value at negative 2 because of that vertical asymptote. We're never going to have an x value at a positive 2 because of that vertical asymptote. So we've got all real numbers except x cannot be equal to a negative 2 and x cannot be equal to a positive 2. Then we go to our range. Our range's focus is on that movement up and down. So what y values can't there be? So we've got that top part of the graph. Everything is going to be above 3. So this is all real numbers where y is above 3. It's not equal to 3 because that's my asymptote. But my graph also doesn't exist at 2 or 1. It doesn't exist until I get down to 0. And it is going to exist at 0 and everything below. So it's all real numbers where y is greater than 3 and where y is less than or equal to 0. All right, let's move on to our last one. We have our equation here. We want to start off with that vertical asymptote. Our vertical asymptote, again, is that denominator set equal to 0. So we have one vertical asymptote at 2. Have our dashed line going there. And then your horizontal asymptote is all about the degree. The highest degree on top is a 2. The higher degree on the bottom is a 1. So in this case, the higher degree is on the bottom. And if the higher degree is on the bottom, that means that there isn't a horizontal asymptote, which is going to bring us to our x-intercept. When we're solving for the x-intercept, we're setting the numerator equal to 0. So we've got x squared minus 2x minus 3. When we are solving a quadratic, we know a whole lot of ways to solve quadratics. The fastest way is always to use factoring if possible, which in this case we can, giving us a solution where x equals 3 and x is equal to a negative 1. Therefore, our x-intercepts are 3, 0 and negative 1, 0. So 3, 0, negative 1, 0. Your y-intercept is when your x value is equal to 0. So we go back to our original equation. We're going to plug 0 in for x here, here, and here. So 0 squared minus 2 times 0 minus 3 all over 0 minus 2. 0, 0 cancels, -3 over -2. So y-intercept is at 0, +3/2, because those double negatives end up canceling. So 0, 3/2 is really 1.5. Alright, so now all we have left to do is to get our graph going so that we can do our domain and range. We start by plugging our equation into our calculator, so go ahead and press pause and get that going. Make sure that when you enter your equation in, you don't forget to put the numerator in parentheses and the denominator in parentheses. And you can look at graph to get an idea of what your equation, what your graph's going to look like. Remember, we had that vertical asymptote at 2, which is showing up right there. So we want to get our points. If our vertical asymptote's at 2, when we go to our table, there it is. Remember, when you see the error message, that's representing your asymptote. So we're going to use the 3 points to the left of it and 3 points to the right of it. Go ahead and press pause and finish up your graph. Alright, let's check how you did. Make sure that you're using the graph on your calculator to give you help on how you should shape your graph that you're sketching. We see that we're going sharply up and then kind of straightening out here as we go sharply down. So make sure that that is shown on your graph. So we've got our domain. As we look at our graph going left and right, it's always going left, it's always going right. The only place it's not existing is at that vertical asymptote. So we see that the domain is going to be all real numbers, except x cannot be equal to a +2. We look at our movement going up and down. These arrows are forever going up and forever going down. As I go up and down, there's no break in the graph going up and down, which means that your range is going to be all real numbers with no exceptions. Alright, that is it for your video on graphing rational functions.